There are a lot of ideas and patterns not being used. I think this time we got a very good team together, with people be able to think in different ways. And they picked up an idea, realized the benefits of it, and put it into production.
That idea was based upon this, a steel bolt. It looks ordinary enough, but the design of this bolt lay at the centre of a £125 million project at Rover in the 1980s to develop a new engine which would see the company into the next millennium. The huge cost of development meant for the designers working on the project that the new engine family was a once-in-a-lifetime opportunity to contribute to new engine design. Conventional car engines, such as Rover's earlier M Series or A Series, are constructed using separate sets of bolts on the top and the bottom of the engine block. This relies on the rigidity of the block to contain combustion forces. It also risks distortion of the cylinder bore. This distortion was of special concern to Rover because, unlike its earlier cast iron engines, it wanted the new K Series to be built around a lighter aluminium block.
One of the problems you see you got with aluminium is it's very good in compression, but not as good in tension. And also, we would like to avoid distortion of the aluminium block and the liners, because that could lead to oil consumption, high oil consumption, which we don't want.
Bolts are good at carrying tension. Steel is good at carrying tension. Aluminium is very light, but it's much less good, less efficient in tension.
So if we could build up a structure or component like layers, sandwich structure, easy flat surface to manufacture, you put them all together, minimum risk of any oil leak, and if you then can go with one bolt from the top to the bottom, you got whole package under compression, instead of having one set of bolts from the top and one set of bolts from the bottom. That's where we start getting the idea, let's get on with this is unique.
A total of 10 long bolts hold the layers of engine tightly together. These help to maintain the shape of the cylinder bore. The idea was not new, but Rover was the first company to manufacture a car engine of this type. Their success in making the idea work was revolutionary. The development of the new engine took 6 years. As the design evolved, it became clear that the long bolts could not be included without rethinking the shape of the whole engine.
We ran the bolts down the outside of the cylinder block on the basis that they would function equally well there. They didn't need to be internal to the engine, and we would save weight on the cylinder block itself. Unfortunately, there were disadvantages with that route. The entry and exit points of the bolt, where they went back into the crankcase and exited from the head, were very difficult to keep oil tight, and as such we abandoned that idea. What we did instead was to extend areas of the cylinder block around the outside of the bolts so that the bolts sat in a cast-in tunnel. That retained some of the advantages in that we didn't have to machine very long holes for the bolts to go through, which would be a lengthy and expensive process, but still kept the bolts functioning as we would wish. There were spin-off benefits. The tunnels gave us relatively large diameter, or large area, they're actually square, large area communication passages between the crankcase itself and the cylinder head. And we decided that we could use these as passages for engine breathing, and also it allowed us to provide a much better oil drainage system from the cylinder head back to the sump. It wasn't something we had envisaged at the beginning. The need to enclose the bolts to ensure oil tightness gave us this opportunity, which, when we'd investigated it fully, was a significantly greater benefit than we would have originally obtained by running the bolts externally.
The plan to use the bolts was suddenly offering elegant solutions. But Rover still had to make sure that the engine would be mechanically stable.
We got a lighter block, but we also got a block which was less stiff than would otherwise have been the case. So it was very important that we made sure that the block was still able to carry those loads which arose from other forces than the combustion forces. In a vehicle, the whole engine beams is the name we apply. What it means is that the engine and gearbox assembly effectively bends as the forces arising both within the engine and from the suspension are applied to it.